Alright, section 1.1 for trigonometry. We just learned about the names of some Greek letters that we're going to use for angles. So now we're going to talk about oriented angles. An oriented angle is where the direction of the rotation is important in identifying that angle. We determine the direction of the rotation from the initial side of the angle to the terminal side of the angle. So I mentioned that earlier, where we start, the ray on the side of the angle where we start, and where we end. Direction is indicated by making the angle positive or negative. An angle that rotates counterclockwise, like opposite of the hands on a clock, is positive. And an angle that rotates clockwise, the same direction as the hands on a clock, is negative. Angles that are larger than 360 degrees simply mean that there is more than one rotation from initial side to terminal side. That means we can name angles in the interval from negative infinity to positive infinity. This will be important when we start graphing trigonometric functions, and the domain of each function is an angle. So we're going to plug in an angle into sine, cosine, or tangent and get out a ratio, and we're going to graph that as like x and y. So x will be our plug in an angle, and the angles we can plug in is all real numbers. But that is chapter 2, so we save that more for later. So let's go on to converting between the 3 units of measurement we just talked about. So to change from degrees to radians, we are going to multiply by pi over 180. And the reason we multiply by pi over 180 instead of 2 pi over 360, because there's 2 pi radians in 360 degrees, is that way it's already partially reduced, right? Because both the top and the bottom would divide by 2. Now the other thing to keep in mind is you always put the unit on the top that you're trying to change to, and you put the unit on the bottom that you are changing from. So since we're going from degrees to radians, we've got the degrees on the bottom of the fraction in the denominator and the pi on the top in the numerator. So if we are changing from radians to degrees, we're going to multiply by 180 over pi. Again, getting rid of radians, changing to degrees. If we want to change from degrees to revolutions, we are going to divide by 360 degrees. Because there's 360 degrees in one revolution, right? So it's kind of like a conversion factor of 1 over 360. And if we are changing from revolutions to degrees, it's going to be the opposite. We're going to multiply by 360. If we change from radians to revolutions, then we are dividing by 2 pi. And if we change from revolutions to radians, then we are multiplying 2 pi. 1 revolution is 2 pi radians. Okay, let's practice. So changing 30 degrees to revolutions, that means we want to divide by 360, or you can think of it as a conversion factor where you're multiplying by 1 revolution over 360 degrees. So we reduce that to 30 over 360, which would be 3 over 36, which is 1/12 of a revolution. Okay, 1/6 revolution to radians. We're changing 2 radians, we're multiplying by 2 pi. So 1/6 revolution times 2 pi radians, and that's in 1 revolution, right? That's why we're multiplying by 2 pi. So that gives us 2 pi over 6, which would be pi third radians. We don't usually write the word radians when it's radians. If it's degrees, we put the little degree bubble. If it's radians, we just don't write anything. And it doesn't even have to have pi. It could just be a number, like 1 radian. We're going to get to that on number 5. Okay, 60 degrees. So 60 degrees to radians, we're going to take 60 degrees, multiply it by pi over 180. If you'd really rather do 2 pi over 360, so you don't have to remember that, you can. It just means reducing 1. So 60 pi divided by 180 60 goes into 183 times. So that answer also gives us pi third radians. Okay, negative 5 pi fourth radians to degrees. So a negative angle makes more sense now that we know about oriented angles. That just means it would go clockwise, right? So to do that, we would take negative 5 pi fourths and multiply by what we're trying to change it to, so degrees. And that would be over the radians that are in 180 degrees. Okay, so let's simplify this. We've got 4 goes into 180 like 45 times, and then 45 times 5, and keep the negative, and the pi's cancel out. So I believe that gives us negative 225 degrees. Use a calculator if you need to. Okay, 1 radian. Look, it's not even something pi, it's just 1 radian. So to change that to degrees, we're going to take our 1 radian and multiply by 180 over pi. Yes, we now have pi in an answer that's degrees. So that would be exactly 180 divided by pi degrees. Or if we'd rather get an approximate answer, we can use a calculator and do 180 divided by a value of pi, as many decimals as you want to do. I'm trying to find pi on my calculator and it's not. Oh, there it is. And I got 57.3, well, 57.295779551. So 57.3 degrees. Alright, so on this assignment, being able to change between radians, degrees, and radians is particularly important and leading us into the next section of material.